Hello everyone, my name is Ray Konopka, and in this session we're going to be talking about how to create composite VCL controls. I've got a lot of material to cover in a very short time, so after a very brief introduction of just what exactly a composite control is, we're going to take a look at creating an address component made up of several different fields, allowing us to edit a very consistent, concise manner of data-aware fields in a database table. Specifically, I'm going to be showing three different techniques on how to create a compound or a composite VCL control. One is the very manual embedding controls process. The second will be similar, except that we'll leverage the subcomponent functionality that's part of the VCL. And then finally, we're going to look at to see if there's a way to visually design these composite controls. So a composite control is sometimes called a compound component or a compound control, or in the .NET space it might be called a user control. It's really just a container component that has one or more embedded controls in it. The key though is that this is not the same as a component reference. When you drop a DB edit on a form and you connect it to a data source, the data source is a component reference inside of the DB edit to that data source. What we're doing is we're actually embedding the subcomponents, the controls, into a container. And as it turns out, the technique to do it is pretty much exactly the same as dynamically creating components at runtime, which if you're a component writer, that's something that you've probably have done to test out your controls. So one of the core benefits of building a composite control is that you can get quite a bit of reuse. If you find yourself building an application or multiple applications and you're laying out the same set of controls over and over again with the same labels, the same sizing, and so forth, if we can group that together into a composite and be able to reuse that over and over again, that's great. And that very nature also gives us a lot of consistency that we can leverage. And so if we want, in my example I'll show momentarily, is this address set of fields. Well, there's a very concise, consistent way of presenting an address, and a composite control can help leverage that and ensure that across your wide spectrum of applications you have a consistent user interface for that. I have performance listed down, not so much as a speed, and functionality once it's running, but in development. If you don't have to lay out all the fields and all the controls and let the component do that, you can do all of that layout once and leverage it over and over again. So to create a composite control, there's several steps that we need to do. The first is we need to define the container. The container needs to be able to hold controls, visual controls typically. So it's going to require a window handle. Typically this will be a T-Win control, a T-Custom control, even a T-Custom panel. Some way to hold the controls that you want to embed into it. We can also decide what properties of the embedded controls we want to surface. We can surface them individually, or we can write aggregate properties that encompass multiple of the embedded controls as a single entry point into our composite control. And then another area that we need to be interested in is, do we need to handle any events of the embedded controls, so that as I change one control I might want to update something else. I might handle those completely internal into the composite, or I might surface those to the user of the composite at the composite level. And so these are all things we have to take a consideration for. And so, as I said before, typically we would descend from one of these common base classes. The key is that the container is responsible for creating and destroying the embedded controls. And that actually is one of the important parts of building a composite control is the management of the embedded controls. So typically what you'll do is create a field for each of the controls, each component you want to create. And the key is you want to specify the container as the owner of the embedded control. So if I had a field called first name and it's a label, I'm going to pass self as the owner. But self refers to the composite, not the owner of the composite. Remember, when we drop something on a form, the owner is the form. And this is the most common problem I see developers run into, is they end up passing the owner into the constructor of the embedded control. So what that means is my address, for example, gets created. The owner of the address is the form that I've dropped it on. Well, if I pass that owner value to the label, that means the form also owns this new embedded label. Well, that's problematic because now the form thinks it owns it. It can select it at design time. You can even delete it, and your composite control will end up causing all kinds of problems because it'll get streamed out in duplicate, and then the next time you load it up, it'll recreate a new set, and it's a mess. So you always want to pass the composite as the owner of those, so it never goes beyond that. Although some developers like to pass owner thinking that, oh, I'll be able to select it at design time and make changes to it. But trust me, that is not the route you want to do. Also important is to set the embedded controls parent property so that it's parented appropriately to the new composite. And then you can, of course, initialize the controls for whatever way you need it. If you need to if you require a window handle, you can override the create window method of the composite in order to get access to like combo boxes and list boxes, which require a window handle to add items to it. So key things when we want to surface embedded properties, we can use property wrappers, which is a way to wrap up one or more properties from the embedded controls into a property at the composite level. We can also use aggregate properties, which take multiple embedded components property values and treat them as a single entity at the composite level. And we see both of these in the address components that I'll be showing in the code in just a second. So here in Rad Studio 10 Seattle, I have the three different examples I'm going to be covering today. The first is called the TRKDB address, and it's the only one I want to focus at this point because it's the kind of the basic get your hands dirty simplistic way of building a composite control. And what we can see is it is a single entity. It's an actual component called the TRKDB address. So the first instance of it is a RKDB address 1. Notice that I can't select any of the controls that are inside of it, but they are fully functional controls. I can go ahead and run this application and start clicking through and navigating, and you'll see that I have the individual fields getting updated from a database table. One thing I don't have set up right at the moment are the last three fields. So let's go and look at how I've done that. And if we look at my object inspector, there's a couple new properties that I've set up. I have a property called data fields, which is a set of the various data field objects that I need to connect to. And I've also registered a property editor for this particular control so that when I expand this, I can drop down and pick the city, go down, drop the state, and pick the state province field. And for the zip code, I'll pick the postcode. And you can note that it's still live data, just like every other data aware control that you have access to. These are all DB edits. This is a DB combo box. And various just regular labels that are put together. And so as I navigate through, I can do that. We can also change the field captions, for example. Let's say I didn't want this to be zip, I wanted that to be, postal code. I can make that change and have each of these labels modified for me. Now they are actual labels, as we'll see in the implementation, but notice that I'm masking that for the user of the component. I'm giving them specialized properties so they can easily control what gets changed and modified. One of these really cool, since we have ultimate control over the layout and the positioning, we can add some extra functionality like change a label position to have the labels be on the left rather than on the top. And by changing that, the components reposition themselves according to that setting. And if we want, we can change that back to that style. So what does the RKDB address component look like? So this particular implementation is in the RKDB address unit, and all of the source code is provided in the download link that will be presented at the end of the session. The quick thing is to just follow along. One of the key areas, I'll come back to this data fields class in just a minute, and we're going to do the same thing for the field captions. We'll come back up, but let's get down to the address component itself. And most often your composite controls will descend from a very basic container. Container meaning it has to have a window handle. Because we're holding other sub-controls, visual controls, we have to have a window handle. So that means it's a Win control descendant or a T custom control. If you wanted a border around the composite, you might descend from a T custom panel or even a T panel, unless you wanted to hide some of the properties. The key piece, though, is that this is where we start to see that, yeah, it is just a container of other components. So I've got a number of DB edits, a number of labels, there's the DB combo box. These are the child controls that I'm going to be manipulating. The data fields is an aggregate property class that I'm using. So rather than define separate fields for each individual item, I create a new class which descends from tPersistent, which is what I've done back up here. These define all of the published properties that I want to have access to, and I'm going to use this single entry data fields over here to get to all of the data field properties of all of my embedded controls. So all the DB edit and the combo box and so forth. To modify the corresponding labels captions, I have an aggregate property called the RK field captions, and so that makes it real easy to have a centralized location to be able to make these changes. So if we go back into the address here, a couple things that most of the rest of this code is all supporting the construction and the layout and access to the subcomponents. So rather than go through each of these individually, let's just go jump into the implementation, and then we'll see how these get picked up. Because what we'll see is there's a number of properties like changing the character casing on any of the fields. We can do that. The field captions I already talked about, field color and label position. But let's jump down to the constructor. And what we'll see is pretty much straightforward. One technique that I do like to recommend in my composites is I actually remove the CS accepts controls flag from the control style. And what this allows or tells the IDE to don't allow another component to be placed onto my composite. Because remember, a composite is just a window handled control, like a panel. So I technically could drop something else onto it, but usually you don't want to. You're already occupying all of the space and managing it. You don't really need to make a general purpose container. You certainly could, but I generally don't. So for each of the labels and the edits, I have a function that's going to help me do that. So I'm giving it a default caption, and I've got creating the various edits that I need. And so what do those look like? So create label, here is where the dynamic nature of creating components at runtime comes into play. One, we just do atlabel.create passing self, and remember, self is now this instance of our DB address. So the container, the composite, is the owner of each of the controls, which means when the composite gets destroyed, then all the child controls will get destroyed for us. The create edit is pretty much the same. Now notice we haven't done any positioning or anything at this point. We've just created the controls, initialized a caption. Here I'm actually hooking an event handler up. So my edit is going to be called the do change event handler inside of my address. And this is, I'm going to forward on as another event that we'll end up using. And then there's the create combo, does the same thing, creating a data or a combo box, again owned by the composite, parented by the composite, and then make sure you set visible to true so we can actually see it. And then what happens after that, we create the state list, which really means populating the state combo box, creating our aggregate properties to hold the individual data fields and field captions, and then at the very end we are going to position the controls. So if we scroll down a little bit, get back after all of this, the create state list, we create a string list that holds all the states, and then we assign that once we do have a window handle for our composite, which means we can now add items to the combo box. So I scroll past all of this, and we get down to the position controls. And what we can see here is that based on the label positioning, it's pretty straightforward. It's a little tedious, but it is set up to position each control where it needs to be. And so the length, height, width, all of that is managed. We figure out the line values and how many lines we need based on the layout, all based on the current font settings. So we're getting some font metrics for that, so that we have enough spacing around everything. When the labels are on top, it's done, a different set of values, usually to line them. The first name and last name are lined to the left. Same thing with the labels. The addresses are all at the 0 position. If you wanted to put margins and so forth, you would accommodate that and make the various changes. So couple things that you probably have noticed, there's quite a bit of code that manages all of this, and anytime we want to get access to something, we have to write the code for it. For example, this composite control has a data source property, which makes sense that each of the individual data aware controls need to know which data source it's connected to. But I also don't want to have to set that every single time. So instead, what I have is a regular data source property that will take care of, whenever I change it, assigning it to all of the individual embedded controls. And I'm just using the first name edit to hold the reference, and that's the one I'm going to return. When I go and assign it, I'm setting all of them to that same value. So I don't have to hold a separate reference to the data source in my composite. I can use my embedded controls to actually hold that stuff together. In order to do the and you'll see this technique used in a number of different places. Character case, whenever we make a change to one, we want to propagate it to all of them, we can do that. And let me see if there was a couple other things for the field captions. Notice that the field caption, and when we do the assignment, we're actually assigning the value to the instance of the field captions that we've created. The field captions will take care of editing all the labels and so forth as they get changed. So the rest of this is support stuff, getting the font height, and setting up our label position. We're doing some sizing to restrict the size based on the fonts as well. So if I go onto the form and I resize that, it won't let me do that. It wants it to be this size based on the font settings and so forth. So the key thing is there's quite a bit of code that's in there, but it does everything that we need it to do. It's got a lot of flexibility. We can't mess up the component or change things that are beyond the intention of the component writer, which is quite cool. So next up, we're going to look at an alternate way of doing a very similar approach, but using the subcomponent technique included in VCL. Next, I'd like to take a look at an alternate method of surfacing your embedded controls properties. There's a specific call for setting a subcomponent, and what this does is it takes all of the published properties of that embedded control and surfaces them at the composite level so that you can modify them. So it's pretty remarkable in all the data that you can get access to very easily. There's two main kinds of subcomponents. The most common one is read-only, which sounds like you can't do much, but you can, because you're really you're setting up a subcomponent, a reference to the properties. The reference itself is not changeable, but obviously the properties of that reference are, and that's what you're modifying. So an example of that is the t-labeled edit label property. It is possible to have a read-write component, a subcomponent, where you can actually change it out and replace it. And when you do, though, there's some extra steps that you have to take into account so that you ensure that the subcomponent framework remains intact. So read-only subcomponents, again, the most common one. The composite must be the owner of the subcomponent, which makes sense if you think about it. We're not talking about component references, outside of our component, but they're all internal. And you have to have a published property for the subcomponent. So that's what the object inspector looks for, to be able to say, oh, hey, you're a subcomponent. Let me expand this and show a whole bunch of the nested properties of that. And then the key is to specifically call set subcomponent in your composite. You can also do it in the subcomponents constructor, but most often you don't have access to that, so you're going to do it in your own composite. But if you were to build a set of controls that it knew it was always going to function as a subcomponent, you could do it there, but typically you'll do it at the composite level. Read-write subcomponents, again, not often, but you can find a couple examples in the VCL source code. The key thing here is that we need to do some extra cleanup. So if we're going to, write to it, we need to be able to free the subcomponent when another one gets assigned into its place. Also, if nil gets assigned to the property, the internal subcomponent should be recreated, and so forth. So let's take a look in the code at the subcomponent version of our DB address. So back into the IDE, we're going to now focus on the second example. Looks very similar to the other one. A couple things that are different. I still can't select anything directly, but you'll note that there's a whole lot more elements, properties inside of our composite here. And these are all the subcomponents. This is, if we, let's say, because I still have to set up the city, state, and zip. So let's find the city edit. And if I expand it, here are all the published properties of that. So I can go and find the data field, drop that down and find the city property, and it'll make my change. I can close this up, go find the state combo, and change its data field. State province. Of course, I have to do a lot more scrolling and changing. The zip edit can go into here and go in and change the layout to the postcode. And then, as you can probably imagine, that as I go in to the label, let's say for the zip label, I can open that up, change the caption to postal code, and if I can even get into the individual fonts of all of this, I can make this one now show up bold and make all kinds of changes to the individual components. So much so that you can actually start changing positioning and sizing and the layouts of things by modifying the various properties inside of this these subcomponents. So there's a lot of flexibility in here, but that comes at a price, because you can also toggle off visibility. Anything that you can change, you can make modification to that. So while it's nice to be able to do that, keep in mind there is some extra noise, especially in this example. Now, if we go in and look at the implementation, let's see what we need to do for all of that. So again, we're going to descend from a Win control, basic container, and we still have our embedded controls. All of this looks pretty much the same as we had it before. We have our create edits, our labels. However, I don't have the data field aggregate property, nor do I have the field captions, because I'm going to get to those through the subcomponent properties directly. So let's go into our what happens when we create these. So let's see, we still share a data source across all of those, and then of course we have all the published properties for these will become the composite, the subcomponents. So there's the first name label and first name edit. That's how we show those up. They're read-only because we're not going to change those. These are being set when we create the different controls. So for the most part, there's nothing a whole lot different, except that when we go and create our components like we did before, let's find our helper functions. And so here's the create label. So again, create the label, parent it, set its visible caption. We give it a name. Now that's one change, that in order for the subcomponents to work, the component has to have a name. Reason for that is that shows up in here. And so we've set up some names, and they're based off of the actual component instance that is being created, which is the RKDB address underscore sub1, and then we get the individual name of the subcomponent that we specify. The key is to call set subcomponent, and you pass true to it. It's kind of odd. There isn't a single example in all of the VCL where false is passed. It means that treat the component as a subcomponent, and it just changes the flag inside of the control style. So you're just always going to call that. So on the component that I'm creating, I'm setting that as a subcomponent, and that's it. The framework takes care of publishing all, expanding this out to show all of the other properties. We do the same thing for the edit and even for the combo box as well. The rest of the code is pretty much the same. We have our list of states that we're adding. We do the assignment. We handle the events like we did before, and even have our property wrappers to get to the data source and the data, the character case and so forth. So pretty cool technique. Next up, we're going to look at how we can visually design our composites. So the cool thing about the compound and composite controls is that we can map and wrap a lot of different functionality inside one entity. However, what we really lack is a visual designer. All the subcomponents that we've been creating are all dynamically created. We have to position them in code. It's not the way we're used to doing things when we're talking about the VCL. It'd be really nice to be able to drop controls down and manipulate them, move them around, set up event handlers, and so forth. Well, it turns out that while we can't use a form because it's not really conducive to what we want to do, it is possible to use the frame designer, which is a very nice visual designer. So what this allows, if you think about frames, just specifically frames, there are some advantages and disadvantages to them. One, frames are true objects, which makes them much more effective than the old component templates, because it takes advantage of full inheritance. So if I make a change to the base, those are all propagated to all instances that are based off of that. So that's very powerful. There are some disadvantages though. Embedded components on a frame are selectable in the form designer. From a frames point of view, that's kind of neat to be able to do that, but if you want to guarantee that you control what is surfaced to the user of the composite, this gets in the way very quickly, because it allows users to modify the embedded controls, which is really what you're trying to stop them from doing. You want to provide more control and surface properties to control that. The problem you have is that you can't add a custom property to the frame. They don't show up. You can add it, but it never shows up in the object inspector. And then on top of that, they're really difficult to deploy because it's like a live solution. You have to deploy it in the repository and then copy it to each anybody's machine. And if you have, a common set that multiple people are using, it can get to some versioning issues. So really are trying to get to something that gets us around these limitations. Well, that's where frame components come in. The idea behind it is that we take a frame, design it visually to what we want it to do, but then convert it into a composite control. And when you do that, you end up addressing all the disadvantages of just using simple frames. The embedded controls are not selectable, which is typically what we would want. The developer controls which subcomponents are modified and how they're modified. And then really a nice feature is that if we do add some custom properties like the label positioning or the data source to get to all of the data sources, so we're not having the first name and last name going to one data source and the city state zip going to another one, or different data source, those will all appear in the object inspector. Some other benefits that we get, we can visually design the control, the composite. That's awesome. We can hook up events, in the traditional manner, double clicking on the controls, visually edit. So design it first, great, but we can go back and open up the frame that is being used for the component and make changes to it. What's also nice is we can deploy it just like any other component. meaning that we put it into a package and we register the component with the IDE, and then go ahead and load that package into Delphi, and it just works. One thing that you may want to do, I recommend this, is you can register a sprig class. There's a T component sprig. The code is inside the sample code that I give you. This allows the composite to work better in the structure pane. That's what the sprigs are used for. And so being able to do that works really well. So let's take a look at the final example of our address, but now as a frame. So in the frame here, a couple things that we'll see. It looks a lot cleaner. We don't have all the extra stuff that we did before. We're going back to the data fields aggregate property, capturing all of the data field properties of the embedded controls. And so I personally think this is a much cleaner interface to have all the data fields in one spot, go in and make the changes to I want of my control. I also have the field captions as well, that I can go in and make a change if I wanted that to be, post code. I can make that change as well. So very nice. What's cool about this whole thing, though, is that when I go to the implementation for it, it's actually a frame. Now I brought over the data fields technique that I used before, but the component itself is based off a T frame. Well, that's how I created it. I created a frame, and here are the individual controls that I've dropped onto the frame and made up the changes. We can even do things like set up event handlers. And so I've put an event handler on the exit of the zip code, and if I've entered in this particular zip code, which is where I'm located, it will automatically populate the city and the state. This is really cool when we can manage that and set this up easier. We could do this in code, but it's so much nicer to be able to navigate and make the change visually, like I'm designing a form, if you will, and position everything out and then surface it. So I really like it being this best of both worlds, being able to visually design the composites. Then we just go and register it like any other component. There's a registration unit that we can use, and you can find that in the sample code. And the registration simply will register the component. So the trkdb address underscore frame, and it will go ahead and install it as a component. And we can find that if you install the components. I got them down at the bottom. Here are the 3 different versions that I have. So this is the frame version, the sub component version, and then the traditional manual approach. So that's all the information I have regarding composite VCL controls. I know there was a lot of information that I kind of threw out there very quickly, but all of the source code of the sample code and the sample components, all 3 versions, are included in the composite VCL control zip file that's accessible from that URL there. At this point, I'd just like to thank everyone for joining, and I will be joining live for the Q&A portion. Thank you very much.
Okay, so I just brought Ray on. So Ray, sorry I didn't bring you on earlier. You should be able to see the questions now.
Yes, it looks like I can. Hopefully you can hear me as well.
I can. So actually, there's a couple questions here that are still for Robert, but oh, here we go. Here are some questions for you. Can you say a bit about the component editor?
I'm trying to think of which component editor, because there wasn't a component. There were some property editors in there, but the address controls themselves don't have a component editor, but the property editor is for editing the fields, to be able to pick the different values. It's actually a pretty standard property editor for editing. It provides the accessibility to have a drop-down list. And one of the cool things that you need to do, like you may notice that I defined the database field properties as type TRK data field. And the reason for that is that type itself is defined as a type of string. So it's just a regular string type, but because it has its own type name, it gets its own RTTI, which means I can bind the property editor directly to that type. Because I don't want to say, give me a specialized property editor for every string type that's inside my component. And I don't also necessarily want to do a specific property name for each one, simply because it could change. And I might have other components that I would use that. And it's much easier to say, if I define all my data fields as RK data fields, then I can simply set the property editor to that. And what it does is the property editor provides a drop-down list using one of the property attributes in the editor, and says it populates it through a callback with the different data fields that are inside of the connected data source.
Okay. He said, yeah, that's what he meant, was the property editor.
Perfect.
So Neil asked me to re-show the download link, so I did. So there's a download link there if you want to grab the session materials. Couldn't design and runtime packages be separated, or shouldn't they be separated?
Oh, absolutely. And in the example code here, they are. The components themselves are in a runtime package, but then the registration unit that registers the components with the palette and registers the property editors with the various property types, and the property editor unit, the implementation of that property editor, is all in a design package. And the design package requires the runtime package for the actual component code. So yes, you definitely want to separate your runtime and your design time packages.
Okay. So there's a question: if your the frames are changing size after you save projects, if that's something you've ever encountered.
The only thing that I haven't specifically seen that with the frames, I've seen it with other controls, but it's usually related to alignment issues, where and this was more of an issue. Well, it actually might be creeping back up again because Windows 10 changed some of the dimensions of things, but when you align a control inside of your VCL form, the client area of the form is based on the metrics that are used on your development machine. So if you have a title bar, it's the height of the title bar, and so forth. And so if you run that on a system that, if it doesn't have a title bar, if you save it at design time, it's possible that what it saved it into the DFM sizing is a bit different than what you're running it as. And there are situations where, based on the order and things are getting created, a control could be resized when it's loaded from the stream. But as a general rule of the frame itself sizing after a load, I haven't seen that particular behavior.
What about creating a kind of component container with certain rules to permit us to add dynamically new components, and the container will only do ordering and positioning of them?
So it is definitely something that you can do. It's a slightly different approach than the composite control type of development that I was illustrating here. But a typical example of that is a toolbar component. As you drop things onto it, you want it to have the toolbar manage the positioning, and the control, the layout and so forth. The same is true for, say, a group bar or a category view on your left side. Even a ribbon control is very similar to that. The key difference with those is that the controls that you drop onto that container are owned by the form. They're not owned by the composite or the container control. So it's like a specialized panel. You would drop your control down. It would you can override some methods and handle some component messages to know when a control gets added to your controls list, meaning that you become the parent of another control or another control gets removed. And then you can use that to reorder, do a realignment of your child controls and control the order and the layout that way. The key difference again, though, is that the container is not owning the components themselves. Now, if you want to do some sort of hybrid, which is you want to have a composite control, it has some embedded things, but then you also want to have an area where you can drop other controls onto it. That too is also possible, but you have to do some special steps to do that. And that's actually a topic I covered in my old book called a drop area. And there's some special streaming considerations that you have to take into consideration when you're doing something like that. Because if you don't, you end up either recreating your embedded controls multiple times each time you load the form up, or you end up losing the controls that are supposed to be contained inside of your little container area.
Okay. Yeah, everybody should pick up a copy of your old book. That's still a good reference. What does register sprig type do?
So a sprig editor, sprig type, is for managing or customizing the structure pane that's used in the IDE. And so in a particular example that I had created here, this was to allow when you see the DB address in the structure pane and you click on it there, and you can expand it and you'll see the data field properties show up in there in the correct order, and it provides access to that, those embedded properties and things through the structure pane. Is it necessary to have that? No, it's really just a structure pane enhancement to make it work better.
Okay. Michael's saying it looks like you modified the IDE's grid height and grid width to be other than the default of 20. What grid settings are you using and why? Oh, okay. I see what he's asking now. I'm guessing.
Yeah. So the default is 8 and 8. And if you go to normally when you install Delphi or C++ Builder and you go into I don't remember, it's in the tools options for the environment, the form designer settings, it's set to 8 and 8. I actually always change that to 4 and 4. The reason for that is it gives me more granularity for positioning things rather than the 8 and 8. It's more or less a carryover of something that I've done going way, way back. And for example, I tend to use 20 is my left indent when I'm spacing, so that I like white space, and I can't get that if I go 8 and 8, but I can if I go 4, 4. So that's really where that comes from.
Yeah, I just looked at options or settings, environment, form designer is where you can find that at.
Yep. Now, one thing I will say about that, the spin edits that are used in that form there are a little finicky. So because when you focus it, you'll see that the alignment of the number changes to the other side of the control. And so you need to select it, type in the new number, and then tab away, and do that for both to make sure that the number you want actually gets stored into the control. And then you can click OK. If you do it with the control focused, it doesn't always accept it as the value you want.
Oh, yeah.
I've seen that before. Another side benefit of doing the 4x4 is that it darkens the main part of the form because there's more dots on it, and it makes other controls on there stand out a little bit more.
Oh,
from a design point of view.
Yeah. Which
I like.
So I have a question for you. Have you thought about revisiting your component book from way back when?
I think about it every time I do one of these presentations. I'd love to. I mean, the cool thing about it is that like almost all of the material is still valid. I mean, that's the beauty of the VCL, that it's stood the test of time, and it's still allowing us to do some really cool things. But again, there's tons of things that I've done sessions on and have covered in certain examples that go beyond that. And I would love to go back and kind of do another edition of it. My biggest challenge is just finding the time to do that. So
yeah,
I have to figure out something to get that to happen, because it's certainly it seems like we're getting a lot of new blood into the product now, and it's certainly a very important feature of Delphi.
Yeah, actually, we get a lot of new tech partners coming on that want to develop components for Delphi and C++ Builder, and we're still recommending they check out your book and your videos and stuff like that. So we see a lot of new people coming on, that's for sure.
That's great.
So
I get the hint.
Yeah. Have you considered cloning?
That I have not considered that. Aside from the moral, ramifications, that might be an interesting way to accomplish it.
Yeah. Okay. All right. Well, that looks like the end of the questions for us right now, Ray. Thank you so much for your time and for all that you do.
No problem.
It looks like we have you again, a double dose of Ray with step-by-step guide to logging custom data in CodeSite.
Yep,
so
should be coming up next.
Catch you on the flip side in about 9 minutes.
Okay, very good.
Thanks.